Okay, this is the video instruction for assignment 13, and with this lesson we are going to have a lot of new vocabulary. So rather than you watching me write down all of these vocabulary words, I'm going to let you pause the video and write down and define all of these words: coordinate plane, x-axis, y-axis, quadrants, origin, ordered pair, x-coordinate. So I want you to pause the video and write down all of these terms and their definitions. Going to move on to the next set of words and next definitions. And again, you'll need to pause the video because I'm not going to leave you enough time while you're watching the video live. Y-coordinate, discrete graph, continuous graph, a relation, domain and range, a mapping, and a function. Pause the video, write down the definitions, pause the video, write down the definitions. Okay, and one more page. We're starting a brand new unit, and every time we start a new unit, there's always going to be a lot more vocabulary. Function notation: input, output, vertical line test, and zeros. I want you to write all these words and the definitions down. So if you haven't paused the video, back the video up, pause it, and write down each of those definitions. You're going to need to know what those terms mean to do the assignments and for testing. Okay. A coordinate plane is a plane divided into four regions for graphing. It's a graph. That's a coordinate plane. Okay. This point here in the middle is the origin. And this number line that goes left to right is the x-axis. This number line that goes up and down is the y-axis. This coordinate plane is divided into four quadrants. Starting up here in the top right, we're in quadrant 1, and then we go counterclockwise. This is quadrant 2, this is quadrant 3, and this is quadrant 4. The coordinate plane is used to graph points, and a point is called an ordered pair. Okay, and it consists of an x number and a y number. The x number is on the number line that goes left to right, and the y number is on the number line that goes up and down. So the x numbers go left and right, and the y numbers go up and down. So if I wanted to label point A, so I start at the origin, I'm going to go 1, 2, 3 spaces to the left, and if I go to the left, that means I went in the negative direction. So my x number would be -3, and now I'm going to go up until I get to A, 1, 2, 3, 4 units. So left 3, which makes it negative, and up 4, which makes that positive. And here I am in quadrant 2. If I want to find point B, I'm going to find my x number first, and the x numbers go left and right. So from the origin, 1, 2, and 2 to the right would be positive. So now I'm here, and I'm going to go down 1, 2, 3, and I went 3 down, which makes that number negative. So right is positive and up is positive. Left is negative and down is negative. And this is in quadrant 4. Okay, the ones that give us trouble are the ones that fall on the axis. So like point C falls right here on the y-axis. So for the x number, I don't have to move left or right at all to get to C. So that would be 0. But I have to go up 2, so that would be 2. And it's not in either quadrant, it is on the y-axis. Point F, I'm going to skip down to point F. From the origin, I have to go 1, 2, 3, 4, 5 in the negative direction. And I'm on it. I don't have to go up or down at all. And that one is on the x-axis. Okay, a discrete graph is a graph kind of like you're looking at here. It's just any points on a graph that's not connected with a line. Okay, so something like this. That would be discrete. It's not connected with a line. A continuous graph is any points on a graph that are connected with a line. So if I had points on a graph that I could connect with a line, then that would be continuous. And it doesn't have to be a straight line necessarily. It could be a curved line, but it's still continuous. It's connected with, you can connect the dots. Not connected is discrete, connected is continuous. All right. A relation. We're going to have a lot of new definitions, and I think this was defined earlier in your other words. It was. It's a set of ordered pairs. The x numbers are the domain numbers. The y numbers are the range numbers. Okay. So in this set of ordered pairs here, the domain would simply be the x numbers. So the domain would be -3, -2, 1, 3, and here's another -3. And if I'm listing the domain, I don't have to list a number twice. If it shows up twice, I only have to list it once. So when we ask what numbers are in the domain, you just need to reference them one time. For the range, that's the y numbers of each ordered pair. So all the y numbers. Remember, an ordered pair is an x number and a y number. So I'm looking for just the y numbers. So 1, 0, 2, -4, and 5. Okay? So these ordered pairs, here's the domain, here's the range. If I wanted to list these ordered pairs in a table, this one's pretty easy. You guys have been doing this for a long time. You just list each ordered pair individually. Now, if you're listing ordered pairs, if a number shows up twice, you have to list it. You have to list each individual ordered pair. But if you're just asking the domain and range, then you don't have to repeat a number. In a mapping diagram, this is where you take these ordered pairs and you put your domain numbers over here and your range numbers over here. So my domain numbers were -3. These are also the x numbers, remember. And I'm going to put the range numbers 1, 0, 2, -4, and 5. So what I've done first is I've referenced the domain numbers in this oval and the range numbers here, and then it's called a mapping diagram because I'm going to map this x number, -3, to its matching y number. And -3 is mapped to 1. Right here you can see in the ordered pair, -3 is mapped to 1. But -3 is also mapped to 5, so I need 2 lines coming out of -3. -2 is matched with 0, so I just map it over. 1 is matched with 2, and 3, that was a 3, that was sloppy. It's matched with -4. So that's what a mapping diagram looks like. I can graph them. I just graph the ordered pairs. -3, 1. So my x number is -3. 1, 2, 3. It's negative, so I'm going this way. And then +1. That's that ordered pair here, -3, 1. -2, 0 means I'm going to go on the x-axis to -2. And on the y-axis, I'm going to go to 0, which means I don't have to go up or down at all. For this ordered pair, 1, 2. On the x-axis, +1. On the y-axis, +2. +1, +2. 3, -4. +3. 1, 2, 3, -4. I'm going down here. And then last, -3, +5, -1, -2, -3. And then 1, 2, 3, 4, +5 would put me up here. Okay, so you can represent a relation 4 different ways: as ordered pairs, as a table, as a mapping diagram, or as a graph. Okay, and you may be giving a relation in any one of these forms. So you could be given a relation as a graph, you could be given a relation as a mapping diagram, you could be given it as a table, or as ordered pairs. So look at number 3. In this one, it's actually given us the table. So first, let's pull the ordered pairs out of here. This ordered pair here would be -2, 3. I'm going to list them right here on the table. This ordered pair would be 1, 2, 3, 4, +4, +2. This ordered pair, I don't have to go left or right at all, so the x number is 0, and I'm going down 1, 2, -3. This ordered pair, I'm going 1, 2, 3, 4, 5 to the left, which means -5. And then 1, 2, 3, 4 down, which means -4. And lastly, this one, +2. 1, 2, 3, 4, -5. +2, -5. So again, the mapping diagram, I'm going to put my domain numbers here and my range numbers here. -2, 4. Remember, the domain numbers is just the x numbers. I'm going to put the range numbers, which are the y numbers, 3, 2, -3, -4, and -5. And then to map them over, I just map the -2 to the 3, the 4 to the 2, the 0 to the -3, the -5 to the -4, and 2 to the -5. And the ordered pairs would be -2, 3, 4, 2, 0, -3, -5, -4, and 2, -5. And my domain is going to be the x numbers, and my range will be the y numbers. So the domain would be -2, 4, 0, -5, and 2. And my range would be the y numbers, 3, 2, -3, -4, and -5. So this is the way that you can represent relations. Now, we're going to start talking about, or we're going to continue talking about the domain and range. And what if you were given a continuous graph, such as this, the domain and range of continuous graphs? Okay. This one is a little bit trickier because we don't have specific points, we have a continuous graph. For the domain, scan your pencil left to right and identify all the x values in which you are touching the graph. I'll show you what that means. If we're talking about domain, we're talking about the x numbers. And the x numbers on a graph go left to right. So if I scan my pencil from left to right, I am going to be crossing this graph no matter where I go from left to right. So this goes to -infinity all the way to +infinity. So it includes every number to the negative side because this goes forever to the left, and it also goes forever to the right. So my domain, I can say, would be all real numbers, left to right. Domain is x numbers, left to right. The range is the y numbers. The y numbers, they go up or down. So for the range, scan your pencil up and down and identify the y values where you're crossing the graph. So up and down. Well, as this thing goes up, this arrow goes up forever. So it's never going to end. It's going to go to positive infinity. But it's not going down forever because down, the graph stops right here. So for the y values, what you're trying to figure out is how high and how low does this go? Well, it goes up forever, but it doesn't go down forever. It only goes as low as, well, that's down to -2. So it's everything from -2 and up. So the range, we identify that as a y, is everything from -2 and bigger. So we can say greater than or equal to -2. Okay, these take some practice, so watch. This circle, the domain, left to right, how far does it go from left to right? Well, it goes out here to -3, and it goes all the way to +3. Okay, so how do I write from -3 to +3? Well, x is less than or equal to 3 because it's 3 this way, but it only goes to -3. So this is how I can write the domain. X is somewhere between 3 and -3. What this says is x is less than 3, less than or equal to 3, but it's also greater than or equal to -3. X is greater than or equal to -3, which means x falls somewhere in between -3 and 3. For the range, that's up and down. How high and how low does it go? Well, it goes up to 3, and it goes down to -3. So it's going to be the same as the domain in this problem, but we're going to use the letter y. So it's somewhere between 3 and -3. All right. For number 4, this parabola goes left and right forever. As it's going down forever, it's going to the left forever, but as it's going down forever over here, it's going to the right forever. So left and right, this thing never ends. So we can say all real numbers. But the range, it doesn't go up and down forever. It goes down forever, but it only goes up to 1, 2, 3, 4, +5. So it's everything from +5 below. So the way I would write the range is y is less than or equal to 5. Okay. One more. This one. Domain, left and right, it goes from -1 to 1, 2, 3, 4, 5. From -1 to 5. From -1 to 5. So I'm going to put an x in the middle, and I'm going to put my signs in. So what this says is x is somewhere between -1 and 5. For the range, how high and how low? It goes as high as 3, 1, 2, 3, and as low as -3. So it's going to be the same as this one up here. So it's between 3 and -3. So domain and range of continuous graphs. Okay, we got a lot of information in this section here, and now we're going to move on and talk about a special kind of relation, which is called a function. Now I want you to differentiate between the two. A relation is any set of ordered pairs. Okay? A function is a special set of ordered pairs. A function is a special relationship between the input values, the x numbers, and the output values, where each input has only one output. Or, you guys remember this trick? The x numbers never repeat. So if I wanted to write a set of ordered pairs that was a function, I could say 2, 3, 0, -1, and 5, 8. See, the x numbers are 2, 0, and 5. They never repeat. So this would be a function. Now if I took those same ordered pairs and I added a fourth one. And I wanted to make it so this is not a function. I can use any y number I want, but for an x number, all I need to do to create something that is not a function is just repeat one of the x numbers. I'll repeat the 2. And this doesn't even matter. I'll make it a 7. Once your x numbers start repeating, it's not a function. Okay? So on most of these, this would be super easy. Just look at your x numbers to see if they repeat. 5, 3, 2, 0, -1. No repeating x numbers. That is a function. Okay. Let's look at number 2. -2, 0, 2, 3, 2. Oh, the 2's repeat. So is this a function? No way, because the 2's repeat. Now, if the y numbers repeat, it doesn't matter. It makes no difference at all about the y numbers. If you look back to question 1, we had a repeating y number, -5 and -5. It does not matter. When determining whether it's a function or not, the y numbers do not matter. Only focus in on the x numbers. If you look at number 5, -3, -1, 0, 2, 3, no repeating x numbers. That is a function. Look at number 8. 1, 4, -7, 4. Oh. Not a function. Look at 11 at a mapping diagram. Hopefully this is a pretty easy concept. You're just simply looking for repeating x numbers. -3 is mapped to 0, -1 is mapped to 4, the 2 is mapped to 7, and the 4 is mapped to 4. So if I made ordered pairs out of these, none of the x numbers would repeat. So that would be a function. Look at number 12. -4 is mapped to 4, -1 is mapped to -1, and -1 is also mapped to 7. -1 is mapped to -1, and -1 is also mapped to 7, which means the x numbers repeat. So this would not be a function. To determine whether it's a function or not, just simply look for repeating x numbers. All right, last concept for this lesson, the vertical line test. If you are given the graph of a relation and you're trying to figure out whether it's a function, you can simply use the vertical line test to see if it's a function or not. And what the vertical line test says, that if you can draw a vertical line through a graph and it touches more than once, if it touches the picture that's drawn on the graph more than once, then it's not a function. For example, if I was to graph this line, no matter where I drew a vertical line, I'm only crossing through the picture that I drew, this curved line, only once. I only crossed through one time. What if I drew it over here? Only one time. What if I drew it here? Only one time. No matter where I draw a vertical line, I'm only going to cross through it one time. Now, to show you something that would not be a function, if I drew that curved line, you can see that if I drew a vertical line right here, I would cross through it not just more than once, but like 3 times. I would cross through it here, and here, and here, and I'd cross through it 3 times, which is more than once, obviously. So that's not a function. So let's look at a few graphs. So 14, if I drew a vertical line right here, I hit that point, and I hit that point too, which means these guys create a situation where this is not a function. They have matching x numbers, -1, -2, -3. This has a -3, and that has a -3 as x numbers. If I look at 15, vertical line only crosses through 1 point, 1 point, 1 point, 1 point, 1 point. Never did it cross through more than twice, so it's a function. 14, no matter where I draw a vertical line at, I only cross through once. Only cross through once. That's a function. This one, if I draw a vertical line right here, I cross through once, twice, not a function. Not a function. That is a function. All right, that's it. Look for the assignment.